Hello everyone, once again welcome to our Computer Science 9618 AS and A-Level lecture series. Our topic today will focus on the database concepts. I'm going to discuss about a few concepts about database and most importantly with regards to a few important keywords and terms or terminologies relating to databases. Next on, we are going to start with some of our key discussions here. We are going to discuss about the limitations of a file-based approach to storage and retrieval of data. This is one of the key reasons why we discuss about databases. What are the limitations of what we call file-based approaches? And moving further, we're going to discuss about features of a relational database that will overcome the limitations or the problem that corresponds to file-based approaches. And of course, terminology associated with relational database model, and a separate discussion on entity relationship diagram to document database design, and of course, normalization to third form, or we call it as the normalization of our tables for arriving at a very good database or relational database. Now, what are the limitations of file-based approaches? Now, let's take a look at this a very simple example of a simple data where if you notice here, it consists of the different names. Okay, could be a record or maybe a logbook, or it's a possible it is a record of a person together with their emails, and at the same time the given IP addresses. If you look at the organization of the file, it's not easy to do some modifications later on, or when you do searching of the different entries. If for example I want to search for, let's say, Blakely here, this one, Blakely Deason, and then if this is the structure of the data, then it would be very difficult for us to look and at the same time to modify later on, or possibly if this data has 100 entries, how are we going to search for this 100 entries? Or when it is going to have another addition of data, probably let's say another 100, so until such time there would be 1000 entries. The problem there is if you look at the structure or the organization of the data itself, it's very terrible. Okay, in my case, very terrible. I would suggest that this should not be the case to record such database. Well, it is considered as a file-based approach. So this is one of the reasons why databases are here, and we incorporate databases in dealing with our data. What are the limitations of the flat file databases? So as you can see here, a flat file database consists of data stored within a plain text file only. So this is a plain text file, and it was saved in a notepad, so it's not what it calls on the organization is not good. Okay, records are stored one per line, and each attribute of the record is separated by a delimiter, often a comma. So if you notice here, the delimiter here symbol is with the use of a comma, often in the form of a comma or tab. A flat file is the simplest form of database. Yes, it is still considered as a database, but there are limitations. There are disadvantages while this flat file is not considered as a very good form of databases. The database can be read easily by human beings or by many different programs, but as the data accumulates, or there are a lot of records now that is going to be entered to that database, problems may arise. Now, a file is a collection of items of data. Okay, it's as you notice here, there's a lot of items here: the name of the person, email addresses, and then even the IP addresses. It can be structured as a collection of records where each record is made up of fields containing a data about the same thing, maybe As you can see there, the first name, the email, and the IP addresses. And of course, the individual elements of the data can be called as mentioned here, it is considered as your data items. When a program is used for data processing, the organization of any records used depends on how the program is written. So oftentimes, when we open software programs, there are some instances that coupled with the software itself or the user interface or simply the program itself, it is together with the database, okay, or the data that's going to be needed in its in its program interface as well. Take for example our AIS. This is a very good an example of product of database, not only in the form of the database, but it's a complete package because everything is there. Even the lesson plans, even the PowerPoint of the students, our lecture notes, okay, can easily be uploaded there. All in one package also, because we can enter the grades of our students there. We can see also the attendance of our students. Okay, so it's a complete package, not only on the database programming itself, but it's a complete package of the software. All right. So records can be fixed or variable in length, and each record may also contain information about its structure. For example, the number of fields or the length of a record. Okay, so let's say one student has a record, okay, and each student has their own records, grades, the student development, and of course, the most important thing is the grades there, and then the different activities also that they had actually participated or coordinated with. Okay, if the records are to be processed by another program, that program must be written to use the exact record structure. If the structure is changed by one program, the other program must be written as well. So case-to-case basis, if you want to change the interface without changing the database, it could be done. But there are some instances that in changing the interface or in changing or if you do some additionals with your front end program itself, so you need to look at the back end, especially the database, if it will affect. Okay, limitations again. Let's take an example, a business a business organization that keeps separate payroll files and sales files. So there is a payroll program. Each file is used by a different application. The name of the member staff and their staff number are stored twice. So if, for example, in the payroll program, you have a separate database for that. So as you can see here, separate database. And then in the sales program, there's also a separate database for that. There are some instances that in the payroll or in the record structure, same name will appear on these two databases. If you notice here, there are two separate programs that is being used here, the payroll program and sales program, and they have a separate database for it. Okay, the problem, there would be a problem later on, because if, for example, you want to update the file database of a person, of one person here in this database, and the person here actually exists in this same database. Okay, we have the sales program database. There would be redundancy and it's not easy to update the files later on. So that is actually one problem, okay, one limitation of a file-based approach. So there would be redundancy because if you updated in this context on the payroll, you need also to update on the sales program in cases that what you do on the payroll program should also be done in the sales program. Okay, it depends on whatever records or instructions that you're going to execute. Okay, again, in a file-based approach, okay, is limited because storage space is wasted when data items are duplicated. So I just mentioned a while ago, my keyword is redundancy. There is a duplication by the separate application, and of course some data is what we call redundant. So why not use only one database in which these two programs here can access the same database? But if you use two separate databases and each program will access a separate database, same with that of the sales program will access another databases, well in fact the databases are actually related to one another, or simply um, one of the records may appear, okay, may have a record also here in the sales program, so it creates redundancy. Data can be altered by one application and not by the other, so that is what we call inconsistency. There exists what we call inconsistency. And then when you do some inquiries later on, be sure that it is also being reflected on the other software program. So those are the limitations. Now here comes the database. Why we are going to make use of what we call relational database, or why is it that we need databases instead of using those flat file databases? A database here is a structured collection of items of data that can be accessed by different application programs. So you only have one single data or a database where different application programs can access the data. So this is to achieve no redundancy, no inconsistency. There is no such thing as duplication already. Data stored in databases is structured as it's a collection of records where each record is made up of fields and containing about the same thing. And we are now going to talk later on with respect to relational database, which is a database in which data items are linked by internal pointers. We'll discover what are these internal pointers. Alright, before moving further to the advantages of the relational database over a flat file based approach, let me bring to you one example of, usually this is the one that I'm using every time, and every now and then we're going to make use of what we call or discuss about databases. So a simple Microsoft Access. You notice here it is a very simple what it calls one, a trading or an inventory of some trading. I mean, we call it as Northwind Traders. So possible this is a very big company that do some trading. So there are some order lists here. There is an inventory and top 10 orders possible. And let's go to the home here. So it is actually being structured in such a way that if you want to to create a new customer order, so there's already an interface here for you to enter the different data. So it's just like when you enter in, let's say, in a hospital, and before you're going to be admitted, okay, they will gather information from you, and of course, yeah, usually there is a desktop computer or a laptop in the front desk to gather the information and to input all of this data with respect to the client or to the patient. Okay, so here it's very organized, and you notice that I can view the inventory. You can just click it there. All right, and go back home. You can just view the orders. What are the orders? The employees. Okay, so it's only in one package. No need to go to another database or to go to another data and look into it. So everything is in a complete package. Okay, that's just an example. All right, what are the advantages of a relational database over a flat file database? Okay, from the given example that I gave a while ago, a business keeps a database of payroll and sales data. And you notice it was already compressed. Okay, a payroll application is used for the payroll and a sales processing application is used for sales. So instead of using two databases, there's already an inclusion of one database only, and whatever application, let's say the payroll application and the sales application, can just access the data here. So that is actually very important feature of a relational database. So no need to have a separate database for payroll application and of course from the sales application. Moving up further, Problems in flat file database approaches can be solved with the use of relational databases. The name of a member staff and their staff number are only stored once. No need to store in a separate database for sales. Any changes made to the data by the payroll application will be reflected or will be seen by the sales processing application and vice versa. The fields are the same and of course in the same order. A database approach is beneficial because storage space is not wasted. So from 2 databases, it was reduced only to 1 database. As data items are only stored once, so it's very evident here, you're going to store it once, meaning there's no more data redundancy as opposed to flat file database. Data altered in one application is available in another application, so the data is consistent, so there is consistency of data. And then inquiries available are not dependent on the structure of the data and the software used, so the data is independent. All right. Now let's take a look onto few terminologies in relational databases that will give you an idea later on as we're going to move into entity relationship diagram and normalization. So a relational database structure can look like a file based structure, so it consists of records and fields. Now a table here is a group of similar data in a database with rows, okay, and for each instance of an entity, the columns, entity or the columns for its attribute. Okay, we have the attribute. We can do some what you call cross check on the different terminologies later on, because there are some instances that a record, okay, is considered as a row in a database. A field is considered as a column in a database. In some discussions, there is what we call a tuple and at the same time an attribute. So we're gonna resolve that issue later on. But for the meantime, okay, a record is a row. Okay, it's a row in a table in a database, and the field or the different entities or attributes in a particular table is, we call it as a field. Okay, so to illustrate, you can take a look at this simple database here. So the different fields here we have here, or the different attributes of this table, we have here the first name, second name, date of birth, and class ID. Class ID. So this is a simple database of a student, okay, having those fields, okay, and these fields, it requires what we call the things that you need to input in each field, and that is now what we call a record. So let's say first name Noor Baig, and then we have here date of birth 9/22/2010, and then class is 7A. So this row here is considered as a record of the student name Noor, okay, having these fields, first name, second name, date of birth, and the class ID. So the column is the field, the row is the record. Files of database are replaced by tables, with each row of table representing a record. So there's already the inclusion of another name of a record. We call it a tuple, sometimes called as a logical record of an occurrence of an entity. And of course, the column that I mentioned a while ago as the field, they can be interchangeably being used as an attribute. Okay, it is also referred to as a field. So again, when you talk about the record, it's considered as a tuple, and of course the column or the field is also regarded as the attribute. Moving up further, there is another discussion here about the entity. What is an entity? Anything that can have stored data about it, such as person, place, event, or object. So for example, the first name, the last name, those are considered as part or an attribute of an entity. Okay, an attribute is an individual data item stored for an entity, so take note of that. An attribute, so they are closely related to one another, attribute and entity. So the attribute of a particular entity is, for example, a human person. So the attribute there, of course, you have your first name. We know your age, we know your birthday. Next is a table. Again, it's a group of similar data in a database with rows, for instance, of an entity and columns for an attribute. So tuple was also mentioned already. All right. Data is shared between applications using databases. So to ensure consistency of data updating is controlled or automatic, so they are so that any copies of a data item are changed to a new value. So there is now the inclusion of how when you're going to update a data, so it should be reflected to other tables or to other part of the database. So that is now with the use of what we call relational database pointers, that we are going to relate or link or connect one table to another. Actually, databases are just a collection of different of tables or different tables that are linked together. Okay, so we have here different types of keys. This will be used later on. At this, we are going to establish key discussions or different terminologies for relational database as we move on to ER later on and normalization. So we have what we call a candidate key. This will be illustrated later on. It is an attribute or smallest set of attribute in a table where no tuple has the same value. Primary key, this is always the very important entity in our database. It is a unique identifier for table, and it is a special case of a candidate key. In our database, especially the AIS, one of the most important primary key that we commonly use is, of course, I'm going to write it here, we have what we call our ID number. So for students, yeah, that's the most important. It is a unique key that is actually that identifies each student, okay, in the database. So when you key in your ID number, okay, your records will eventually, okay, will be flashed on the screen, or depending on the construction of our the program or the database. Secondary key is a candidate key that is an alternative to primary key, so we're going to look into that. We are going to verify later on what are these candidate keys, okay, and how are we going to look into whether it is a secondary key or a primary key or a candidate key. All right, and the other one is we have what we call the foreign key there. We call it as a foreign key, a set of attributes in one table that refer to a primary key in another table. So the primary key in one table, which is used as a primary key, is also a primary key in another table, meaning it became as a primary key in another table. So we call that one as a foreign key. All right. A database of chemical elements contains, these are examples already, contains a table elements with attributes, symbol, name, and atomic weight. So the name of the table is elements with attributes or with the fields called symbol, name, and atomic weight. All of these attributes are unique to each element, and all are considered as candidate keys. One of these could be chosen as a primary key, so possible the symbol, okay. Of course, no two elements in the periodic table and no two chemical elements have the same symbol, so they need to have what we call a unique identity or unique symbol. Then the other two attributes, the name and atomic weight, would be considered as secondary keys. So that is to illustrate. More to come, we're going to discuss about the ER diagram and attributes of a table. So this is an example already as shown here. Okay. So the creation is, there are three attributes: symbol, name, and atomic keys. All of these attributes are considered as candidate keys. Okay. And of course the symbol here, okay, the field or the attribute name as symbol is already regarded as or considered as a primary key. Okay, take note, the symbol here, okay, each elements in the periodic table has their own unique symbol. And secondary keys, your name and atomic weight could become a primary key, or could become also a foreign key or secondary key in another table. Okay, so, and the last one is, another example is, most tables have one candidate key which is used as a primary key. So this is an example of a database of a student name. So you notice here, it is very obvious that the student ID here, this one on this field, is regarded as a primary key and a candidate key. Alright, so that would be all for the basic concepts for database and introduction already also to a relational database with key terminologies and key terms that is very vital for our discussion for the succeeding topic. That would be all for me. Thank you very much.